Welcome to CS3308 Information Retrieval. This is the Unit 1 Lecture Part 3. During this lecture, we're going to talk a little bit about index efficiency. Now, in the previous lecture, we started to talk a little bit about the process of creating the inverted index and the fact that we're going to build our dictionary, and from that, we're actually going to attach what we call the postings list. And basically, the idea is it says every time I find a new word or a word in a document, then I want to go make sure that I attach the document ID to that word as part of its posting list. And that gives me a way of saying if I'm looking for the word transcendental and it's in my dictionary, then every document with the word transcendental would actually be in the postings list. Now, obviously, as you can think about this, there's a lot of words in the English language, and there are a lot of languages other than English. So these dictionaries and these posting lists can become very, very large simply because there are so many words that we might want to capture and so many terms. I probably neglected to say that, but I can actually capture things in my dictionaries other than just basically words. So abbreviations or maybe mathematical symbols and formulas, all of those kinds of things might be pieces of information that I would index as well. So the problem is these indexes can become very large very quickly, and I've got to have some strategy on how to make that efficient. Now, we did talk a little bit at the end of the previous lecture about some of the techniques we might want to use to do that. So we mentioned this idea of stop words, for example, and the idea that we have these low information value words that are very, very common, and therefore, let's just not put them in the index. We mentioned stemming and we mentioned lemmatization. So what we're going to do in this lecture is cover these in a little bit more detail. So stop words or the stop lists, and basically these are just functional words or function words that just don't bear a lot of useful information. In English, we have a bunch of them. They are things such as of and in and about and the word and in many cases, or with, I. So all of these types of things don't have a lot of information value. When we say information value, nobody's going to go out there and search for a document that says I. It just doesn't happen, right? It's in the document, but nobody's going to be searching for it because, quite frankly, you're going to get an awful lot of documents. There's just no way to know how it's relevant to the question or the problem that individual is looking for, trying to solve. So these idea of stop words, we come up with a list of them, and generally what we do is we just don't add them into our index. So we tend to have a list of these words. Maybe we put them into an array, or maybe we put them into a special dictionary. And whenever we're processing a word to create and add it to our inverted index, the first thing that we're going to do is we're going to go check our list of stop words, and we're going to say, is this one of the stop words? And if it is, we just stop processing and we move on to the next word or the next term that we would need to process. So removing these stop words will typically improve our information retrieval effectiveness, and the reason why is because it's going to make our index a little bit shorter, and when I have shorter indexes, they're a little bit easier to process. So there are a few very standard stop lists that are commonly used out there. We'll have some examples of that as we go through the course. Stemming, the next thing. So stemming, and I want you to just give you this visual. If you ever kind of think about a branch on a tree, right? And off the branch comes a series of leaves, right? Well, if you think about it, the thing that all of these leaves attach to, we can refer to as a stem. And so the idea behind stem is it's saying, let's just kind of get down to the basic thing, the root, if you would. Get rid of all the extraneous information and try to get it down to the most basic concept. And so that's essentially what stemming is all about. It's all about taking terms and reducing them to their roots before we add them to the index. Now, if you think about it, in English, we have a lot of words that start the same and then end differently. One example as we have here is things like automate, automates, automatic, automation. they're all related to each other. They all kind of have the same meaning. They're just used in different ways in a sentence. However, from an information perspective, they're pretty much equivalent. That's a great example of a word that you might want to stem. So you might want to get rid of all of the stuff where it starts to becoming, different. In this case, get it down to automat. Another great example of this is the present tense, past tense, future tense endings on words. We see that often in the English language, and you're going to see that exist in a lot of other languages. In fact, one of the languages that has one of the greatest benefits from stemming is the Finnish language. Finnish it tends to have a lot of different endings on words. In fact, my own last name is Finnish, and there are all kinds of different forms of my last name based upon present tense, past tense, future tense, past particles. So you might be Taipala, Taipalus, Taipale, depending upon the situation or the usage of it in speech. So the idea of stemming is that we reduce all of that stuff just to get down to the most basic term, because I don't want to keep all of them in the dictionary. And quite frankly, if I'm searching for automatic, right, and I have a document that has automate in it, it very well may be very relevant to what I'm looking for, but since it doesn't exactly match, I'm not going to find it. So this also becomes a way of improving the efficiency of finding information through stemming. One of the things we're going to use in one of our assignments is Porter's algorithm, and Porter's algorithm is just a basic and very common algorithm for doing stemming in the English language. This is one of the challenges of information retrieval, is that every language is a little different in terms of the rules and how you have to make it efficient and how we need to index it. So Porter's happens to be a very effective algorithm when the documents that we're looking at are English. I might need to have a different algorithm for different languages. Okay, but Porter's is very popular. There is an example of Porter's that is going to be provided in the assignment that we're going to have as we start developing and building our own inverted index. Some of the typical rules in Porter's is in particular, this is around the English, is that the SSES type ending, we're going to eliminate those. The IES endings, we're going to, the IONAL and ATE type endings. So basically all of these very common changes in endings in English, Porter's has the ability to identify and remove them. And basically the idea is that we're just going to get rid of that portion when we store the word in the index, because it allows us to get down to the root. Stemming, does that really help? There's some debate about that, and I mentioned the fact that some people think that it's more useful than others. In English, the results have been mixed, although they tend to demonstrate that stemming is helpful. In other languages, it is even more useful. So in some cases, Spanish, German, Finnish. The reason why, and anyone that kind of studies Spanish and German knows that there are lots and lots of different conjugations of verbs, etc., and the stemming can actually help us get down to the root of those words. Finnish, again, very significant performance gains in Finnish, I should say, sume, due to stemming. Lemmatization, let's just kind of look at that for a moment. So basically the idea of lemmatization, where stemming is just chopping a word off. We're just going to chop off the endings. Lemmatization tries to get to common meanings. Okay, so for example, in English, to be and are the same word in different forms, right? So it's the same word. Oh, and is, are, to be are the same essential word is just in past, present, future tense. And so what lemmatization is all about is trying to identify these and consolidate them down to a single root word. Now, hopefully you're recognizing the fact that when I do this and I stick it in the index like this, when I actually put in the search term, I would have to do that same kind of conversion of the search term so that my search term is going to match what I've put into my index. But essentially that's what we're doing with lemmatization. Here's a great example. Am, are, is are all forms of the word be or to be. Car, cars, cars, apostrophe, s apostrophe, which is possessive or plural possessive, all the same form of the same are, same root word, which is car. So again, lemmatization, similar to stemming in the sense that we're trying to reduce the complexity of the words and get down to the roots. Stemming is really about just chopping stuff off. Lemmatization is really about trying to identify words that might be different but mean the same thing, and then just to use one form of meaning.